All right, so this is a basic differential equation. So I need to find f. So I know the second derivative. I know the y-intercept, the output when x is 0. And I know what the slope is when x is 0. Okay, so basically I start at the second derivative and I go and I find the first derivative. So the antiderivative of the sine is negative cosine. The antiderivative of cosine is sine. If you remember, if you want to check that, take the derivative of negative cosine, you get negative sine. Take the derivative of sine, and you get cosine. So you know you're right, and there's some constant attached to that. And we can solve for C. I'll call that C1. We can solve for C. F prime of 0 is 3. So that is the negative cosine of 0 plus the sine of 0 equals plus C1 equals 3. So cosine of 0 we know is 1, sine of 0 is 0, which means that C1 equals 4. If I add 1 to both sides, plus 1. Okay, so that allows me to write my first derivative as f prime of theta equals negative cosine theta plus sine theta plus 4. Okay, repeat and find the function. F of theta equals negative sine theta minus cosine theta plus 4 times theta. Okay, so a little tricky with the sign. So what I do is just take the derivative of this to check. So if I'm just not too sure, I'm going to check that one. F prime, the derivative of negative sine is negative cosine, because derivative of sine is cosine. Derivative of negative cosine would be negative sine, and then plus 4. And now I'm pretty sure that that's right. Okay, so because that's what I have over here. So now I can plug in the initial condition, f of 0 equals 5, negative sine 0 minus cosine 0 plus 4 times 0 equals 5. So that guy's gone, and again, we end up with negative 1. Oh, sorry, plus, I forgot my constant. Plus, this is the reason we're doing this, to solve for C2. So that should say plus C2 in there. So negative sine 0 minus cosine 0 plus 4 times 0 plus C2 equals 5. Negative cosine 0 is negative 1. So let me come over here since I'm running out of room. Negative 1 plus C2 equals 5. And it gives me a value for C2 of 6. Okay, so back to so here's my answer. And I'll save myself a little bit of writing. I solved for C2 right over here. I solved for C2 and I got 6. So I'm just going to replace C2 with what it's equal to, 6. And that is my function. That if I take the derivative, twice, I should get this. And if I plug in 0 for the function, I should get 5 as an output. And if I plug in 0 for my derivative, I should get 3 as an output.